Agriculture is the backbone of Bharat. With over 70% of our rural population depending on farming for their livelihood, the Kisan is the true architect of India's food security. Yet farming in India remains one of the most unpredictable occupations in the world. Our farmers face a constant, high-stakes gamble against the monsoon. A delayed onset of rains in Vidarbha, an unseasonal heat wave scorching the wheat fields of Punjab, or an abrupt withdrawal of the monsoon in Andhra Pradesh, each of these can mean the difference between a successful harvest and financial ruin. For millions of small and marginal farmers across India, accessing precise, actionable weather data is not a luxury. It is a matter of survival. Existing tools often provide generic, city-level forecasts that completely miss the microclimate variations that matter at the field level. My project, the Weather-Based Agricultural Advisor, a Kisan Sahayak built for India, tackles this by transforming raw, real-time meteorological data into a simple, high-confidence farming recommendation, helping our producers move from reactive guesswork to proactive, science-backed decision-making. You might ask, why build this as an automated agentic system? The answer lies in the transition from information display to intelligent assistance. A standard weather app, whether it is the default app on your phone or a generic portal, simply shows you the temperature and rainfall probability for Nashik or Bhopal. But it leaves the hardest part entirely to the farmer. What does this data mean for my crops? My system acts as an autonomous Kisan Sahayak, a farmer's advisor. It doesn't just fetch data, it orchestrates an intelligent workflow. It consumes location coordinates for any tehsil or district in India, analyzes multi-day precipitation probability during the critical Kharif or Rabi sowing window, and runs that data through a logic engine to provide the one thing that truly matters to a farmer: what to plant and when. It abstracts away the complexity of climate data so the user receives one clear, actionable instruction, designed for a farmer in a remote village with limited bandwidth, not for a data scientist in a city. The architecture is designed for speed, transparency, and precision, and built to work within the realities of India's digital infrastructure. It follows a clean, three-step pipeline. First, the user provides a location, for example, Ludhiana in Punjab or Warangal in Telangana. We interface with the Open Meteo Geocoding API to convert that plain text location into exact latitude and longitude coordinates. Second, these coordinates are sent to the Open Meteo Forecast API, which returns a high-fidelity 5-day weather profile, including temperature highs and lows, precipitation volume, and probability. This is especially critical during the June to September southwest monsoon season, or during the October Rabi sowing period. Third, this weather payload enters our rule-based logic engine. Instead of relying on a heavy machine learning model that demands cloud compute and training data, we use a deterministic, code-based approach. This means a farmer in rural Chhattisgarh with a basic smartphone and a 2G connection can get a reliable crop recommendation instantly. Every decision the system makes is auditable, repeatable, and entirely reliable. No black boxes, no surprises. Let's look at the engine in action. When a user enters their location, say a farmer from Ahmednagar in Maharashtra, the system doesn't just retrieve a string of numbers. It calculates the climate profile for that 5-day window. If the logic detects consecutive rainy days with high precipitation probability, it adjusts the crop recommendation to account for high moisture soil conditions, flagging crops like paddy and sugarcane as suitable, while warning against sowing groundnut, which is sensitive to waterlogging. If temperatures exceed the threshold critical for wheat germination, a common scenario in the Gangetic Plains during an early onset summer, the system flags heat-sensitive Rabi crops and recommends alternatives. This is the power of a logic-driven agent. It isn't guessing. It is applying agricultural science directly to your local forecast, and it does so in milliseconds, without requiring the farmer to interpret a single chart or graph. For the build, I kept the technology stack lightweight and robust, a deliberate choice aligned with the vision of Digital India and the goal of reaching the last mile. I used JavaScript's native Fetch API for seamless communication, ensuring the application remains fast and functional even on the low-bandwidth rural connections that are common across India's Tier 2 and Tier 3 regions. By choosing a deterministic, rule-based system over complex deep learning, I prioritized accuracy, interpretability, and accessibility. This project is proof that you don't always need massive AI models to deliver massive value. Sometimes, high-quality open data and clear logical rules are all you need to empower a community, to give India's 140 million farming households the kind of precise, timely guidance that was once available only to large agribusinesses. The Kisan Sahayak is for every farmer. Thank you for watching.